All right, we're going to start out here with part of a presentation, actually, that Derek and I did at Wild West Hacking Fest in Deadwood this year, and we thought it would be a great intro to this discussion today. After we do this sequence of slides about the technology itself, we're then going to allow Derek to take the helm and do some demonstration work for us so that you can see some real life examples of how you might apply some artificial intelligence in your day-to-day life, right? So first of all, artificial intelligence, why is it important to information security? This is a little bit of stating the obvious, right? We have enormous demand for our skills in this industry, right? We have a training deficit for sure. We have a skills deficit. We actually have an entire human resource deficit in information security. The demands keep coming, things keep scaling up. There's going to be always a need for our skills in this industry, but there's going to be a need for us to be able to scale ourselves up in such a way that we can be more effective at our job. So the point of this need to accelerate task completion is probably the biggest take-home point that artificial intelligence offers to us in the information security realm. And then, of course, for your more executives in the house, potential for some cost reduction by applying artificial intelligence technology. Right? We're still in the hype cycle, right? Everybody out there with various products would like you to think that they have cracked the nut, solved the problem, that all of their AI and ML, machine learning in their products is the most wonderful thing since sliced bread, and they are your ultimate solution to everything. No, we're in the hype cycle. We're totally in the hype cycle, and it was completely emphasized and blown up to an intense scale when we saw these generative AI models emerge in the industry with ChatGPT and all of its other friends, right? Frankly, there are multiple opportunities for us to apply data science, artificial intelligence, machine learning to information security problems. Let's move away a little bit from the hype cycle and focus on some real problems. Time series analysis, is a classic. All the time, what we're doing in our industry, I don't care if you're on the offensive side, defensive side, forensic side, whatever it is, you are looking at logged data somewhere, sometime, and you are looking at timestamps. And so there is opportunity for AI technologies to accelerate your tasks, maybe even to build task-specific models to help you in those kinds of tasks. Text classification, no doubt, that's a natural language problem, very, very helpful to apply that in the information security paradigm. Anomaly detection, something we talk about with task acceleration, is an analyst's sixth sense, right? This idea that you're maybe a defensive engineer or a forensicator, and you need some way of validating something is true, right? You're like, I think this is right, but let me have my friend here, this large language model, this generative AI, give me a little context so that I can interpret that and use it as my aid, as my friend, as my buddy, if you like, right? And then, of course, we have the offensive side against AI technology itself. We can attack AI technology, especially generative models. We can attack the fact that they represent a data input parameter boundary that we can use against the technology to make it do interesting things. But wait, why don't we get some meat on the bones first? Why don't we define a little bit about what artificial intelligence actually is? The actual term was coined a long time ago, in 1955, by John McCarthy. It's the science and engineering of making intelligent machines. Concepts such as autonomous systems that can independently plan and execute a sequence of steps in pursuit of a specific goal, right? Machine learning is a part of artificial intelligence, studying how our computers improve their perception, knowledge, and thinking by leveraging data. Deep learning, another concept, the use of large multi-layer neural networks organized in a human brain-like configuration. Something you'll hear me say a lot when I'm teaching and talking about artificial intelligence is that all of these layers that we are going to talk about still ultimately add up to this concept of simulated reasoning. A large language model, a generative artificial intelligence system is simulating thinking from a large data source and spitting out tokens to you as it simulates that thinking, responding to your prompt and your context. Artificial intelligence is not brand new. I hate to tell you. I know you might think that artificial intelligence suddenly popped up about 3 years ago. It's not true. It actually grew out of neural network research starting back in the 1950s. There was a real life problem that had to be solved back in those days. And that real life problem, believe it or not, was echo cancellation on telephones. It was a telephony issue. And Bernard Widrow and Marcian Joff at Stanford at the time developed some AI models to do this, developed some, essentially at that time, were neural networks called Adeline and Madeline, which solved this problem of real-world phone echo. In fact, the neural network model's job was to actually predict bit values. Can you actually compute and predict what that next bit value is going to be? And if it's not what it is supposed to be, then maybe that's an echo and I need to cancel it, right? So this is multiple adaptive linear element was the name of the model. Now, unfortunately, or maybe fortunately, I don't know, it depends how you look at it. There's always opportunity everywhere. As we grew through the 1960s and 70s, the early phases of compute development, the von Neumann computer architecture actually was the dominant paradigm. And the von Neumann computer architecture is characterized by this serial architecture that is a computer processing unit that goes out and fetches an instruction from memory. It executes that instruction, and then it puts the result back into memory, and it does that in series. And unfortunately, when artificial intelligence and neural network research was going on in parallel with the dominant von Neumann architecture that was emerging in early computers, there was a realization very quickly that neural networks didn't really operate well in a serial fashion. In fact, the research was saying that neural networks need to perform multiple operations in parallel, and the von Neumann architecture just really didn't suit that. And so the research around neural networks kind of stagnated because of the emergence of the compute paradigm, the dominant compute paradigm at the time. However, in the 80s, some of this research got reinvigorated by a gentleman named John Hopfield at Caltech. And I find this interesting to compare and contrast against Moore's law, right? We all know the Intel gentleman who came up with this law of compute transistor density accelerating over time in a sort of exponential kind of fashion. This scale is deliberately not linear. And it led me to think, how does the von Neumann architecture, which is, a serial-based architecture, and then the emergence of GPU parallel compute architecture, how does this impact the paradigm that Moore's law mandates, right? Well, it doesn't really mandate or speaks to, I'll say that. And what it really is that TPUs, tensor processing units, and graphical processing units, GPUs, they represent a simplification of the von Neumann architecture with performance improvements that don't necessarily rely on smaller transistors. GPUs and TPUs are computational specialization. They're specialization on vector processing. They are specialization from a speed and algorithmic efficiency perspective. My opinion is tensor and GPU processing don't really break Moore's law. They really extend the paradigm of increasing computational power. These are the things I think about when I'm sitting on my deck in the evening with a nice cocktail in my hand. Derek's laughing at me. Thanks, Derek. Love you too, man.
I'm laughing because it's true.
It is true. It is absolutely true. I think part of me, and this is why I teach at Antisyphon training. I just want to take a segue right now and say I love to be an instructor. It is something I think I was ultimately born to do at this time in my career and in my life. And so there's a little bit of a computer science professor in me, which is why I'm going through some of this sequence, right? Let's look at the historical AI tech timeline. In 1966, the year of my birth, ELIZA was developed at MIT by Joseph Weizenbaum. 72, we had the statistically trained natural language processor. So very early days, we're already seeing natural language processing emerge. The things in red that I've highlighted here are monumental developments that have changed the paradigm from the perspective of the large language model evolution. So in particular, there was a seminal paper in 1997 that spoke to the long-term, short-term model that was developed by Hochreiter and Schmidhuber. It's called LSTM. And LSTM is the core neural network layer that makes large language models actually be able to remember context. It actually allows them to be, in a way, a little less stochastic. They can sort of go back and forward in time instead of being in the moment. And it's a very, very interesting paradigm and algorithmic development. Coincidentally, or maybe not so coincidentally, in 1999, NVIDIA first introduced their GPU. These were the prerequisites. These were the seminal events that led us to the idea of neural network machine learning, natural language models starting to be released and develop more rapidly. So in the period 2000 to about 2016, we have a lot of experimentation going on with multiple new AI models being released, and IBM and Facebook and Meta and Google all involved, right? OpenAI was funded in 2015. That's when that startup was spun off, right? 2017, we have the introduction of the transformer model at Google. And the transformer model set up this idea of being able to use neural networks and tie it in with this concept of transforming and generating from the neural network processing. I'm trying to be I don't want to go too deep because then we get into class, but all right. 2018, Google made TPUs actually available, and then OpenAI publishes a paper on GPT. Now we have what is the beginning of the root of the tree on natural language processing becoming large language model and generative at this particular junction in time. In 2019, OpenAI releases GPT-2, and suddenly we have kind of an arms race of technology on our hands. Now, coincidentally, right there at 2019, something awful happened on planet Earth, and that would be the COVID pandemic. And so maybe this was meant to happen, because between that time and today, with a lot of scientists ensconced in, well, their home offices, there was this massive research period, and then all of a sudden an explosive growth of AI large language model deployments. Okay. By the way, some of these images are generated from DALL-E 3, which is a visual AI model that you can prompt it. I used a simple Python script and say, draw me a picture of explosive growth. And this is this is one of the pictures that came out, which was a tree with, I think it's fruit, and then some numbers exploding out of it. Kind of cool. Anyway. Another picture from the LLM Practical Guide, which is out there on a GitHub, shows kind of the root of this tree in 2018, and then this growth of the different branches. And it also shows for you the incredible popularity of the decoder style transformer model, otherwise, as we otherwise know it, the generative large language model that really started to push out in this explosive growth. So we're in an interesting point in history, right? We have these very, very large compute clusters. We finally had the compute power available to us. We finally had the data storage capacity available to us to build these very, very large neural networks and connect them with this transformer model paradigm. All right. So pretty quickly thereafter, right, we came, various people said, well, how do we know that these models, which are simulated reasoning and generative, how do we know what they can do? And so they started testing them, right? And this, if you set human performance as a baseline at the 0 mark here, which is about 3/4 up the slide on the screen, and then you use different domains of knowledge against the various AI generative models that we have, somewhere right around 2018 to 2020, we suddenly discovered that these simulated reasoning generative models actually were meeting human baseline for reading comprehension, image recognition, language understanding, handwriting recognition, speech recognition, predictive reasoning. That's interesting. Do you notice that predictive reasoning is a little bit lower and later in time on this particular graph? And, we talk about that a little bit. And we start moving into more and more complex domain knowledge, right? Code generation, more complex reasoning. Now, look at complex reasoning. 2023 to 2024, about where we are now, complex reasoning is still subpar. It is below the human baseline. The question you got to ask yourself is, for how long? Another way to cut this apple was we started looking at standardized testing, and standardized testing in the United States is a long and glorious tradition. I'm an immigrant, by the way. I grew up in Australia, and I entered this world of standardized testing much later in life, but I'm aware of many of these things. So GPT-4, which was released in 2023, we tested against these various standardized tests, and you give it the unified bar exam, and it came in the 90th percentile. LSAT 88th, SAT 97th. I mean, GPT-4 did better on the SAT than I did. I guess I've outed myself now. GRE, US biology, AP calculus, et cetera, right?
Joff, it did better than most people.
Most of us, right. As compared to GPT 3.5 back in 2022, which was not that long ago. By the way, the older you get and you start looking at 10 years ago and going, oh, I think I have T-shirts older than that. So not that long ago, we were seeing numbers in the 10th percentile, and suddenly GPT-4 is in the 80th and 90th percentile. So what that means is somewhere in about mid-2023, we developed for ourselves a simulated reasoning model that was as capable as an intelligent high schooler. What does that actually mean? Socially, ethically, morally? I mean, we got some interesting things going on here and some interesting things to think about. Okay. Now, the other thing we learned very quickly was to train these models takes a ton of compute resources. This is a graph of training flops from situational awareness.ai, which speaks to the evolution of time of the amount of floating point operations per second we need to actually train these models. And boy, when you get up to Gemini and GPT-4 in 2024, you're in 10 to the 22nd, 23rd, 24th power of floating point operations per second to train these models, okay? That means an awful lot of electricity, which I'm going to mention in a minute, but these things are not small, okay? In fact, where are we, right? Current frontier models like Llama 3 are trained on the internet. I love this. I like this sentence. And the internet is mostly crap, right? So we've trained a very smart high schooler on a diet of, well, McDonald's, for lack of a better word, right? Hey, sorry if you're a real big McDonald's lover. I'm not. Mostly junk data, right? So if the vast majority of their training compute is spent on mostly junk, what would happen if you could spend the same compute cycles training a model on extremely high quality data? I think what would happen, I would just make a little prediction here, that we get much better than a smart high schooler, that we start getting into the space of a pretty capable simulated reasoning entity. So, and again, a lot of this is from the situational awareness papers published by Leopold, and you can go look some of this stuff up. Leopold, in his papers, proposes an idea for where we're going in this whole journey that we're on. So the concepts here are, as we accelerate into the future, orders of magnitude in pursuit of acceleration are pretty much our best guesses as to upcoming changes between, let's say, we'll look at this between, say, now, more or less, all the way up to about 2027. From a compute perspective, we're not going to see that slow down. We all know Moore's law is there. We all know that Tesla, Google, NVIDIA are working very hard on processing power research and scaling. So we're going to see predictably a 2 to 3 order of magnitude improvement in processing power. We'll also see continuous improvement in algorithmic design, probably with a 1 to 2 order of magnitude improvement. And then where it gets really interesting is when we start unhobbling the training of these models. And by that, I mean, when we start dropping the guardrails and using a pre-trained intelligent high schooler model to start training the next model. We used reinforcement learning techniques. We start feeding the output of LLMs that we know is high quality back into the input side for training. We start accelerating up and unhobbling, right?
And by hard to quantify, I think we mean anywhere from like 1 to infinity.
1 to infinity order of magnitude. So if we look at the projection, and I think this is more or less coming true as this was written last year, we're starting to see artificial intelligence becoming a knowledge worker partner to what we're doing. We're moving to instruct model, to chatbot, to agent level. We're really getting to a point where things are becoming incredibly useful, okay? So if today we have LLMs that are smart high schoolers, they're able to ace the ACT, solve college level math, accelerate tests, et cetera, et cetera. If we add together these predicted order of magnitude improvements that Leopold proposes, then I think our predicted intelligence may well transition over time, and I don't disagree with this statement, where we go from what is currently a pretty smart high schooler to a simulated reasoning level from a generative AI model that becomes something akin to a knowledge-driven PhD level researcher. Huh. And it gets worse or better. I don't know. Turns out you think about it. Because once you have that first even smart high schooler or that first knowledge-driven researcher, you can start hooking these things together. And you can automate the AI research. So if we automate and we scale up the AI research using existing artificial intelligence, we're starting to take the guardrails off and we're starting to scale very, very rapidly. And what Leopold Aschenbrenner predicts is, and again, this is, you know, crystal ball stuff. So just bear that in mind, that we may well be in a position of having, you know, 100 million automated researchers working at 100 times human speed, not too long after we automate that AI research. And so the prediction is that it's plausible we go from what's called artificial general intelligence to something of the order of superintelligence. And if we do that, what use are the humans anymore? So here's another graph from that particular set of papers, and I do strongly encourage you to go read them. I think they're very interesting. So we're sitting here today, and, you know, based on the predictions of these papers and everything that we're seeing transpiring, we're actually looking at the beginning of an exponential acceleration curve in this technology. And we are seeing all of the technology companies positioning themselves to begin accelerating up that curve as fast as they can. All right. There's another researcher named Roger Gross, who's a computer scientist at the University of Toronto. He's a founding member of the Vector Institute at the Advanced Canadian AI Research. Sorry, let me say that again. He's a founding member of the Vector Institute to Advanced Canadian Artificial Intelligence Research. Roger sees the artificial general intelligence trajectory over the next decade that looks a little bit like this. And his biggest concerns are those that have already been expressed by OpenAI and others in the community, are essentially, where are the alignment risks and challenges? And a lot of the world in the past year or two has been focusing the alignment risk and challenges kind of to the left of this curve, you know, reinforcement learning, selecting outputs that humans approve of, using chains of technology. You know, that's kind of where we are right now with these base LLMs as we train. But we're starting to move up the curve. So long-range coherence makes the LLMs useful for generating proposals, for brute force searches, right? Policy gradient, more effective, et cetera, et cetera. But as we kind of go over the top, and we'll go over sort of a peak where we suddenly have really big alignment risks. And in fact, there was a governance and alignment entity that OpenAI had running for some time. And I think a lot of those folks just quit. They didn't know how to solve the problem, right? And the sentence here to the right of the model is very prescient. As the model becomes more capable of solving problems through search and reasoning, why should it imitate humans anymore? I mean, are we even useful at that point? Did you watch The Matrix? Because we are kind of in this position of being somewhat in the matrix in this world. If you ask data scientists that are training these really large clusters, they cannot give you a precise answer of why the LSTM neural network layers in their models are actually operating in the way that they are. And so they're concerned that the word simulated in simulated reasoning is starting to break down, and maybe it's not so simulated anymore. Now, again, a little bit of hyperbole, a little bit of excitement, but it is a concern. Now, let's talk about electricity. And this is where I draw a little bit of comfort for this slide, but not the next one. The United States is in a big problem right now, and that is we are fast approaching the threshold whereby we cannot generate enough electricity to run these very large compute clusters that are training these models that we're all aware of. In fact, we will very quickly approach the intersection of maximum electricity capacity to train these models. So as you're looking at your media, you are seeing suddenly a great deal of interest by very large technology companies in locating themselves near abundant sources of electricity, or even further, acquiring entire power generation ability so that they can solve this problem. Okay. Derek mentioned earlier, as we were starting up, that Microsoft is currently in the process of considering starting 3 Mile Island nuclear reactor back up. That scares the living daylights out of me because we're talking about 1970s technology. So good luck modernizing that before you start it. But anyway. Now, it turns out, just if you're not worried enough, China doesn't have this problem. China has happily been burning as much coal and producing as much renewable. In fact, China is just producing as much electricity as they possibly can produce through all means, whether it's coal, gas, renewables, wind, you name it. And to make things more interesting, in the artificial intelligence community with large language models and other neural network models, we are openly publishing these models on public-facing websites. So the geopolitical risks as we continue down this path are going to amplify immensely. In fact, you will see, I'll just throw a prediction out there. In the next 12 months, you will see artificial intelligence as a military concern become front and center in the United States and elsewhere.
I think I had a little bit of an internet lag, but that actually might be happening now. I just read an article here recently where I guess it was Llama 2, the Meta model that was released. I don't know, it was 2022 or 2023.
Yeah.
So yeah, an outdated model by I guess current standards. But I guess the Chinese were able to take that and essentially make a military AI out of it. At least that's what researchers are claiming. And so, I mean, I think it's the cat's out of the proverbial bag, kind of thing. The Pandora's box has been open, whatever cliche works there, right?
So I do that. That is actually the introduction sequence to our class, in fact. And we're setting a context here, right? To do a little bit of scare the crap out of you, but also to motivate you. You need to understand this technology, not just because you're a technological practitioner in information security. Artificial intelligence is going to dominate our lives from a multiple paradigm perspective for a long time into the future.
Yeah, I think even if it's a technology where the bubble bursts to a degree, right? Where let's say that, those orders of magnitude hit some kind of limitation and we get basically everybody gets a PhD, like level researcher as your assistant, which would be kind of cool. I would like to have that kind of thing, like an analyst sixth sense, kind of thing. I think that it's kind of like as new technologies have come out in the past, right? When virtualization came out, cybersecurity practitioners had to kind of learn, like be conversant in VMs and virtual machines. Same thing with Docker and containerization or cloud technologies, right? There's all different things. I mean, at the very least, it's going to be a technology that you're probably going to be running into in the future, even if you're not now. I mean, we have clients now that are having us test large language models, custom implementations in their organizations. And so, that's going to be a thing that's coming if it's not already, I guess,
Yeah.
probably already here.
Yeah.
And this is we're actually not going to have time to go through all the slides even in this hour presentation. And
This
so
is a
this
great slide, though, Derek. I want you to walk the folks through this slide. This is a good
Yeah,
one.
I was gonna say this is a good segue, and then I'm gonna have you jump to like slide 36, I think is probably where we want to go. So this is like I said before, large language models are just a component of like the overall AI and machine learning ecosystem. And so you've probably heard some of these terms, said before, even if you're not into AI, so to speak. Where all of these different components kind of like build upon each other. Like you can't have an expert system, an AI expert system these days without leaning on concepts that came from machine learning and neural networks and deep learning, because large language models are essentially like, basically bolting a lot of this stuff together in a lot of ways. And so I think if a lot of the stuff that's in this slide here, we're actually going to cover in more in depth in our class. Like what is linear and logistic regression? What does that do? How do you use it? And then we have hands-on hands-on Jupyter notebooks that are going to be walking you through how do you use these? What can you apply it to kind of thing? Like how can you take away something? And actually, we're going to talk a little bit more about large language models, and I'm going to show you a quick demo of something, and then I'm sure we'll be at the top of the hour by then. So yeah,
Yeah, so we're going
let's
to go
say,
forward a little bit. This was a good one. Why don't you talk to this one real quick,
oh,
Derek?
okay, cool. So I guess this is kind of like I got over the pandemic, like kind of what I did for summer break. Over the pandemic, I went and got a master's degree in data science, and people often ask me like, why did you as an information security practitioner get interested in data science? And I think because that's basically it goes all the way back to like when sneakers came out in 1993. Is that I think 92 or 93? Back then, Cosmo, I think, was the character who said that the world is data, right? And like data, I'm sure you've heard data is the new oil. Well, a lot of what we do is as InfoSec and hacking type, in this profession revolves around making sense out of the data. And I feel like there's a lot of overlap between hacking skills and math and stats and machine learning and just overall data science. And one of the things I think that security practitioners would benefit from is just kind of approaching looking at the world that way. It's all text and data, and we need to manipulate it and make sense out of it, especially like when it comes to log files and things like that
Yeah.
on the blue
Yeah.
side, right? Um,
100%. So let's jump to slide 36 now.
yeah. So, what is a large language model? So basically now when people say AI, this is what they're talking about, right? And so, sorry, I guess I'm getting a telemarketer call. No, at least it's not an election call, I guess. Um, uh, and so large language models, I mean, they're fascinating technology. And so, essentially, like Joff is saying, they take all of like this vast amount of data, and it's essentially well, the way I like to look at it is that it's kind of like a superposition of the knowledge that you fed into it that then you can get output back out. And so, like when, if you one of the things that you should look at and kind of like a novel concept for large language models and the way that one of the ways I look at it is, it's essentially a really large scaled up next word predictor. So if you've ever been typing on your phone and it says like, hey, what's the next word? Basically, that's an algorithm on the back end that's predicting what the most likely next word will be. But then it's scaled up to this thing that's essentially a bunch of neurons running in a GPU that's as big or bigger than a human brain. And it's kind of interesting that I heard an interview with Sam Altman on, I think, the Lex Friedman podcast, where he basically admitted that OpenAI really doesn't know what's going on inside of ChatGPT, like what's actually happening in there, and which is also kind of terrifying, right? I actually shouldn't probably terrify you anymore.
Yeah,
So
I think
go
I
to the
did a
next
pretty
slide.
good job of that.
Yeah, right. And so, and we'll go into more in depth in the class overall, like how do these things actually work? But it's really practically like how do you use them? And so one of the mistakes that I made early on using large language models is I was treating it just like it was Google. And I mean, I guess I won't say that's wrong, right? Like you can go and just like type in a phrase that you couldn't Google and it'll give you something back, or you can type in a question and it'll give you something back. But it turns out, very interestingly, the better you ask the question, the better results you get back. Again, kind of like a smart high schooler, right? You can give them a simple instruction and you might get something that you didn't expect as the output. But if you give them like much more detailed instructions, then you'll probably get a better result. And so that's what prompt engineering really is. So this is where we're going to take like a better type of prompt or question to the large language model and get a better result out of it. All right, next slide. So a little bit of terminology. When we talk about writing a prompt and interacting with a large language model, there are a couple of concepts. The first one's a token. And essentially what a token is essentially a word. It can be a word stem, character, or punctuation or something like that. Really, most of the time, a token is going to be word. And why is that important? Because that's kind of like the measure. Well, it's important for getting billed, right? Because I think they bill on token usage, but also the context window. And what that means is essentially like how big of a question can I ask? I have this window of data that I can send into the large language model and get data back out of, and that's usually like a window of size. And at the moment, I want to say that the popular big models that are out there are 128,000 tokens, I
Yeah,
think.
128,000. Yeah, 128K token, which is huge. The
It's
context window.
pretty huge, right? And then I know I heard earlier this year, and I know we're getting close to the end of the year, that by the end of the year, OpenAI was talking about 1 million token context window, which is dude, that's a lot of data. And so why is that important? And there was a question earlier. I was answering some of the questions in the Teams chat. I'm sorry, I didn't get to the Discord chat because it was updating in the background and then it had an error, computers. Um, but when you train one of these big models, right, that once it's trained, it's pretty much that's like, look at it as kind of like a snapshot of that like training, right? And it's really expensive to do. And once that model is in use, the context window is kind of how you catch it up to where you are, right? You give it more information so that it can give you a better result, a better output. And then an agent is something that is essentially like an autonomous piece of software that's going to interact with the large language model and perform some kind of function. Remember, if you were here during the pre-show banter, I mentioned that there's a company now called DropZone.ai that claims they have a built-in or a drop-in SOC knowledge worker where you basically have a SOC analyst and it'll work tickets for your SOC. Now, does it work? I have no idea. I don't believe in it enough to give it the money at the moment, but this kind of stuff is coming. And so why is this important? Because next slide. Somebody, I see so the little like shocked faces are floating up my screen. That's funny.
Yeah, I love those. Um,
Um, So inner fabric. Now, this is something that Daniel Miessler put out a while back ago, and those prompts that I was talking about. Essentially, what this is, what fabric is a collection of curated and engineered prompts, like ready for you to use. And as all awesome hacker tools are, it's command line. And so essentially, you'll take text and feed it into Fabric, and on the back end, Fabric is going to go and query your text to a large language model. And remember I said earlier, and I'm going to reiterate this in case you're shocked out of remembering this, is I'm sure that AI is going to take jobs in the future. 100%. I do think that's going to happen, but will it take your job? Well, I mean, the more you learn about AI and the more you can do with AI, and if you can use it and increase your own productivity, you're going to be better than that AI in a lot of ways. So I like to think of it more of AI is meant for us to flourish, not for evil corporations to replace us with
Yeah,
AI.
let me drive a fine point on that just for a minute, Derek. There's two concepts here. One is the quality of the prompt that you're pushing into the AI determines the quality of the output. And so you, the human, have to engineer that prompt. Okay. The second point is your experience in properly interpreting the output of the generative AI as to its accuracy, its quality, and usefulness is an extremely important point as well. If you just blindly trust a generative AI, you are going to make egregious errors. If you,
Well, I mean,
yeah,
so to that point, like I hear people all the time say, "Well, the AI could be wrong," right? And 100%, right? And then somebody asked a question about hallucination earlier too. Now, I hope your coworkers aren't hallucinating on the job, but have you ever had a coworker be wrong? Do you believe everything your coworkers tell you as to be like fact that you'll blindly like believe, "Oh, well, Bob told me this, so it's got to be true," right? Maybe you have some people like that, right? But I mean, I guess what I'm saying is, we're hackers. You got to question everything. It doesn't make sense to you.
yeah.
And so, yeah, good point. And well, now it's demo time.
Oh, by the way, this image was generated also by DALL-E 3. And I think what we did, Derek, and correct me if I'm wrong, is we said, hey, man, what if we make MC Hammer into a data scientist? And if we ask DALL-E 3 to depict MC Hammer as a data scientist in his lab, and I can't remember exactly how we
It
phrased
was
it.
something like, data scientist MC Hammer telling us it's demo time,
Right.
right?
And this is
And
what we got. And I think it's hysterical. But
I'm
anyway,
actually most impressed by it spelling its demo time correctly. Like that's actually what impressed me the most, I
I,
think.
I, I freaking loved it. Anyway, I'm
Yeah.
going to let Derek share and do a little bit of demo with
I mean,
Fabric.
that's actually, hey, this worked out timing wise pretty well, I think. Okay, so I'm assuming that everyone can see my window. Please say something if you cannot. But we're talking about fabric, and
I
so
can't see it.
can you not? Ah,
I cannot see it. Try
well,
again. Love you, man. But
I'm glad that
there we
you can.
go. Now we're good.
There we go. Second time worked. So we're talking about fabric. So fabric has this concept of patterns, and you can stitch together patterns, and you can actually make an API server that's a loom. So there's kind of like, a theme going on there. We're really just going to talk about the patterns. And if you look at the patterns that they have, actually, let me do it this way instead. So we'll do fabric dash list. I think it's just list. Or maybe it's list patterns. Oh, maybe I don't know.
There's nothing like live demos to
Yeah,
get the
okay. And it
juices
changed
flowing.
to Python. Well, so they updated it to Go, and I'm pretty sure they changed that flag. But we're in the directory, so we'll just look at the patterns. And so there's a ton of them in here. And the one that Daniel Miessler likes to demo, or I've seen him demo on YouTube, is uh let's see. Which one is the one that he used? Analyze. Analyze presentation, I think. No, extract wisdom. So
Yeah,
let's quickly
extracted wisdom.
extract wisdom. And so again, with this idea of a smart high schooler and us giving them very specific instructions, because as the parent of a high schooler, I know the more specific I am in my instructions to my teenager, the better results I will get. Hey, can you clean your room? Sure. Oh, wait, you left all the dishes in there. Can you clean your room, take all the dishes downstairs, please? Oh, yeah, thanks. Yeah. So, kind of the same thing here, right? So, your identity and purpose is you extract surprising, insightful, and interesting information from text content. You're interested in insights related to the purpose and meaning of life. My favorite part, take a step back and think step by step how to achieve the best possible results following the steps below. Then we give them, some steps, and we're going to want things. Basically, the idea of this prompt, I'm not going to read the whole thing to you. Go get Fabric and read it yourself, is to extract in the best possible way wisdom out of the text we feed it. Now, let's feed it some interesting text. And what I'm going to do is the same thing that Daniel Meisler does. And let's say that you didn't make it to Wild West Hackfest 23 and you wanted to see Joe Gray's talk on the truth is out there, but you really don't have a time to see it today because you came to our webcast instead. So thank you. But
And
so
you were
what
very wise to do that.
and so what you can do now is you could if you don't know, YouTube has a transcript for all the videos that are out there that with a API key you can pull down. YT is a Go application again that Daniel Miesler wrote,
Yeah,
and
just hit enter on that. Show the transcript.
oh yeah, good point. And so basically this is going to be the transcript for Joe Gray's talk. And so basically it's a wall of text. And I know that, online me scrolling up is not the best possible scenario, but basically all of the text that came from that video when YouTube so graciously ran it through a natural language processing model and gives us the text so we don't have to do it ourselves. And so what we're going to do is we're going to feed that into Fabric and do SP. So we're going to stream the results, and we're going to use the pattern called extract wisdom. And it's going to go off on the back end. And the model that I'm using is ChatGPT-4, I believe. Good Lord, it's fast. Using this on the local llama model is not the same experience because I don't have $1 million for GPUs. And so anyway, the idea is now I can take and replace one wall of text with another wall of text, right? So let's go back up here to the
But
top.
the difference is this is well-structured text.
Yeah. So we get a summary. The speaker discusses techniques, challenges, and tools in open source intelligence, OSINT, and related fields, emphasizing critical thinking, privacy biases involving digital landscapes. That sounds really interesting. I should probably read that or watch that talk. Goes into the overall ideas and then gives me some insights, quotes, which is actually kind of interesting. A broken clock is right twice a day. There's always a shred of truth in every conspiracy. Oh, I like that quote. So anyway, you get the idea. We're using AI to go off and take what would have taken an hour to watch the video and essentially giving us a condensed version of the most key takeaways, which I think is fascinating, right? And so we have 3 minutes left, and you might be thinking, well, that's really great, but that's kind of like a novelty, right? Well, how about this one? Let's say, actually, let me
This
do this.
this is the part, Derek, where you say, "Here, hold my beer." Okay, I've got your
Hold my
beer, man.
beer, right? So Joff and I created one, like let's pretend that you're a sock worker and you ran across a command and you're not really sure what that command does. Now, yes, you can Google it and use the man pages for sure, but I'm gonna do history rep ssh.exe. Yeah, because I've done this one about 1 billion times. And it's funny, when I did the local llama model as an anecdote, I ran this command twice, and the llama told me, man, I've seen that command before, because I was still in the context window.
Derek, clear your screen, put it at the very top.
Yeah, actually, let me do this first before I do that. So let's look at that pattern. So CD, analyze, command. Oops, I should have just CD'd into it. And then,
Yeah, so while he's doing that, this is a prompt that Derek and I constructed. All right.
yeah, and so we give it an identity and purpose. You're an expert in operating system commands used in Windows, Mac OS, and Linux. We also still want you to take a deep breath and think about it. We give you the output sections. And my favorite part, again, with this, I could just Google it, right? Actually, it's not in this, so this will be perfect for the demo. So let's go ahead and let's run that command.
Analyze command. Okay,
And
here we
so
go.
it's going to look and see what this SSH command does that I found. Man, it is fast.
How
All
often
right.
do you guys utilize Google anymore? Just curious. Do you mainly just throw everything in like some type of LLM, or are you guys just
It's probably
going between both?
I
80,
balance
20.
between both. Yeah.
Right.
Yeah, I'd say 80% large language models, 20% Google.
So
Depends on the
this was really
question.
cool. We actually surprised ourselves with the level of specificity that the large language model came back with the appropriate prompt. I mean,
Yeah, exactly. So here's my command ssh.exe, username, host, a bunch of command switches. Basically, this came from an IR. I wrote a blog post on this, and it's definitely is a backdoor, SSH living off the land backdoor. And so it gives me, what the commands are, the breakdowns. I asked it to do that. Give me some example uses. It tells me that there's malicious use to it, a backdoor. Hey, I mean, it is spot on, right? What if I had to uh, make a quick change to make it more useful to a SOC worker? And let's say I wanted to come down here to the bottom, and I want to say provide a Sigma rule for detecting the command, and save that. And let's see. Ooh, let me clear my screen. Oh, that's not the right command. Will
drum roll,
create a
please.
Sigma rule. It's like the punchline, right at 101. Aha.
And there's the Sigma rule. Yep.
And so, oh yeah, so sometimes it doesn't get the flags in here. Now, can you copy and paste this into your sim and it be a rule? Man, probably not, but it is a good place to start to write a rule to detect that SSH command. So again, I still think we're at kind of like the beginning or the infancy of using large language models, but that's kind of a quick and dirty demo, and obviously more to come in our class.
So we're going to take the needle off the record. Thanks for watching, everybody. Derek and I are very excited about what we're putting together here for you. We really, honestly, would love for you to come to the class. I think that a lot of the community, with the amount of effort and thought we're putting into this, and is going to get a lot out of it. I really do think this mission is a worthy mission. So, and with that, I guess over to you, Zach.
And
Oh,
one
awesome.
thing, so
Go ahead,
it's
Derek. Yeah.
class in December and then also in person at Wild West Hack Fest in Denver.
That's right. And I put a link in the chat for y'all for the class, so you guys should be able to see all the options there for what's coming up. So yeah, if you guys are interested, definitely check out their class. And thank you guys for being here to share your knowledge. It's always fantastic having you guys on and learning us something new, if you will. You guys always go in depth with this with the AI, and I love that, man. So thank you. You guys have a couple minutes for some questions?
Yeah, sure.
Awesome. Right. There was I think this one's going to kind of relate directly back to your class, but they said there's been a lot of about the info. What about the sec? How are we going to keep LLMs from leaking info they shouldn't? For example, there are already attacks that can directly extract training texts. A forward-facing chatbot that can leak the company data it's based on could be a significant concern.
And is a
Yeah.
fantastic question.
That is. Well, offensive large language model penetration testing is emerging quickly as something that has to be done.
Adversarial AI.
Yeah, adversarial AI work is something we are going to talk about. We are engaging in because that is definitely a concern. And you're right on target, right? Because we're going to have a lot of corporations out there that download one of these base models and then they fine tune train on their own internal knowledge base, and then they put it online as an interactive application for their customers. And so they directly have an exposed attack surface. And
Yeah, so
yeah.
there's a couple of things about that. So yes, there are model related attacks, like for extracting data for sure. At the moment on the big models, the big like chat, OpenAI and Anthropic, and I think that they're probably already doing those types of evaluations. And so really, I think it's going to be custom implementations and we're already doing some of those types of tests. And I think it's a field that is emerging. As far as this class, we'll be talking about it. We're not going to be like the hands-on part is not going to be adversarial AI. That is a class that is likely coming in 2025.
Yeah, we'll touch upon it though for sure.
Yeah, but we talking about for most folks probably on this call, I would say the biggest thing that you have to worry about at the moment is your internal company data leaking out through people using various large language models without any kind of regulation. And shout out to all of the compliance and GRC folks. Hi, Kelly. I think that what I would first do is I would get a policy created in your company about
yes,
AI.
100%. We created a policy at Black Hills very quickly through a working group, and all companies need a policy on artificial intelligence technology use as quickly as possible.
Didn't expect that from hackers, did you?
Josh Hankins says, "Don't train or ask, don't train AI on DOS commands, and we'll be safe forever." So
so yeah, that whole obscurity is security argument. I mean, it's just not going to work, right? Yeah, the genie's out of the bottle. The question is, can we exert enough governance, right, around it, and can we, for domain-specific applications, can we appropriately test the guardrails to make sure that it's as secure as we can make it?
Thank you. Sorry, I was getting a message about my kids from my wife, so I had to make sure I answered that.
Yeah.
Going through what level of knowledge do you expect a student of your AI for cybersecurity professionals 2-day course to have? I'd like to enroll, but wanted to make sure I'm prepared to learn.
What's going to be very, very helpful is we'll do quite a lot of work in Jupyter Notebook and in Python scripting. So if you have not learned how to script in Python, I would 100% invest yourself in that. That would be extremely helpful to you. And this is a total, I didn't mean this to happen this way, but I do have a course in Python coding. So thanks for I'll give you the $50 bill later, Zach. But yeah, if you want to take my on-demand Python course, I mean, it's a good way to get skilled up. I
would agree 100% because there was a point when I was doing the data science masters where I was literally dreaming in Jupyter notebooks. So if you're going to do data science and AI type hands-on work, I mean, to get started, there's nothing that beats Jupyter and Python. There are other things out there, but I would for information security specifically, the overlap with Python. I agree with Joff 100%.
Right. Good, strong knowledge of command line fundamentals and Linux operating system stuff is also really good to have, I would say. And then the other thing is, you don't have to be an expert in statistics, but if you can sort of get yourself, if there was any skill I would want you to bring is a little bit of familiarity with how a statistical regression works and how how a Bayesian network, phishing detection, just a fundamental understanding about how that works is the kind of stuff that would be nice to bring into the class. If you could, that's an optional.
Yeah.
It helps you to be thinking in that kind of mode, I would say.
Yeah, I agree. People get wrapped around the axle of, oh God, math. And so there's no doubt about it. I'm not going to lie and sugarcoat it. There's a lot of math that's involved with AI. But again, like with other things in InfoSec, if you understand the concept and essentially like what is it doing, you don't necessarily need to be a math expert unless you're actually doing like research and development in the data science space, or you're working for
Right.
one of these like big companies where you're working on new models, then yeah, you probably need a math degree, right?
Yeah.
But if you have an understanding or like a high school statistics kind of stuff, I think you'll be in good shape. Like basically, I think right now the only equation, well, no, that's not true. The only equation you probably really need to know is like the slope of a line. If you look at the linear regression equation and you haven't taken stats or calculus in a while, it might scare the crap out of you. But slope of a line, high school algebra.
Yeah, high school algebra kind of stuff, like max, mean, median, basic
Yeah.
statistics is good. It's good to bring into the class as
Yeah.
a knowledge set. And then think about the other thing I would encourage people to do is think about your day-to-day domain specific tasks that you're trying to solve and how you might map those over to artificial intelligence, because those are the conversations we would want to engage in with you. Because I think the fundamental problem that everybody is having is what I would call the square peg round hole kind of scenario, where people want to hammer their problem into like an LLM, but they don't have a methodology, or maybe they're trying to approach it the wrong way, or maybe it's just not the right tool for the job. And one of the things we're going to do in the class is introduce you to actually some task specific data science that is not large language models. And for some problems, some task specific data science is better suited to solve the problem.
Yeah, exactly.
Thank you guys. I have a couple questions here left, but if anybody else has any other questions for you, is there a good way to get a hold of you guys? Reach out in any way?
Yeah, you can find us on LinkedIn for sure. Check that out. You can probably find me on X, Twitter, although that's a floating barge of flaming dumpster fire right now. So I may not be on there for a while. LinkedIn's probably the best spot to find me right now.
Yeah, I don't social media a lot because I'm old and curmudgeon-y, I guess, and it has nothing to do with the current state of the world or anything. I don't know, have other things to do. You can try Discord if you don't get an answer. Maybe poke somebody on Discord for me. You can always email me. My email is derek@blackhillsinfosec.com, but again, I might miss it. So if you do try and get in touch with me and I don't give you an answer in a day or so, please poke at me.
Yeah, and what I would say to us too, if you're communicating with us, kind of, we're in the last sprint of developing this class, and if you have a domain specific suggestion, help us help you.
Yeah,
We're happy to
100%.
we're happy to take suggestions. Yeah.
We're gonna close it out here with this question, and before we answer this question, I also want to let everybody know we are going to be doing an AMA session after this. So if you have the Zoom application installed on your device, at the bottom of your screen, you'll see breakout rooms here in a second, and we'll open up that AMA room here as soon as we finish up this question. Everybody's welcome to join. It's a very open format. Any questions you have regarding cybersecurity, certifications, your journey, resume help, interview help, we're here to help you. So with that said, we're going to ask this last question and then we'll kick that room off. So Mark G actually asks a really good question. That is, what if I'm 60 plus years old and have never been good with math or programming? Sounds like a class is a waste of time for me. What do you guys think?
What's your goal? I would answer the question with a question. What is your actual goal? Where do you want to go? And think about that. I'm not a spring chicken either. And I think that the secret, if you want, it's not even a secret. The key to survival in this industry is to surf technological waves. And
Yeah.
I have made a career of doing exactly that. So even if you don't have a specific goal and you just want to surf the wave, by God, my friend, surf the wave. That's a philosophy I live by.
Yeah, so I would say, yeah, exactly. I echo what Joff says. Like, what do you want to get out of it? Did you get anything out of like the history section of the class? I mean, if you did, then I mean, I'm sure there'll be other things that you get out of the class, but I'm definitely not going to, lie and say there's not going to be coding in the class. However, the notebooks that we give you basically will run themselves, right? Like it's, basically for demonstration purposes. Will you like as part of the lab have to do some coding? Oh yeah, sure. But if you don't, I still feel like that you could go through the notebook and get the examples and actually like learn from it, right? So like Josh says, it's up to you. If you're like, hey, I never want to code, then maybe not, right? Because I think that this is really geared toward folks who want to like dive in to AI. And so yeah, I think the fact that you're here at the webcast means you're interested, right? So I would say, yeah, if it doesn't scare you to learn about it, again, I think you'd find that for most things like AI, like you don't really have to get into the math. You just kind of have to understand like what it's doing.
All right, conceptually, yep. And that's all we're going to do, by the way. We are not, just be clear, in the class, we are not going to give you a theoretical mathematics or statistical degree in 2 days, right? I
Yeah,
mean,
we're not teaching linear algebra. Like it's
yeah, we're
not.
not teaching linear algebra. We may have some knowledge of that, but this is a 2 day AI class, right? So it's going to
Yeah.
be applied
Yeah,
technology.
we want you to come away with it with something you can take back to like work and like make a difference, right? And if the only thing you take out of that or even this talk is that we need to have an AI policy because this stuff is scary, then I mean that's enough for me. That's a win.
That's a win in and of itself. Yeah.
Awesome, guys. Thank you so much for being here and sharing your knowledge with us. It's always appreciated. I know everybody has loved what you guys had to share.
Oh, good.
And it looks like a lot of people will be joining your class as well. So
Sweet.
now at this time, we're going to get started in our AMA, but come back next week. We're going to have Tim Fowler here joining us to talk about, well, cybersecurity and space, hacking space systems. So stay tuned for that. It's going to be a lot of fun. But until next time, we'll see y'all later and we'll see some of you in our AMA. Take care, everybody.
Bye bye.